see my screen currently?
Yes, I can see it.
All right. Okay. So, welcome to this class. So, before I start, I'll just briefly introduce myself. My name is Rising Odegwa, and I'm a data scientist, machine learning engineer, also a software engineer, and you can call me like a jack of all trades, kind of like that. So, I use Python a lot. I use Python for web development. I use it for machine learning, very popular in data science and machine learning. And I also use JavaScript. But today I'll be talking about object-oriented programming with Python. So I believe I sent this notebook yesterday. So maybe I believe most of you will have it, and you should be going over it with me during this class. I also believe that most of you have like played with it, and even some of you might even have a good understanding of what we'll be dealing with today. But it's always good to learn again and just to refresh your memory. Okay, so before we start, I would like to just inform you that there are different types of programming paradigm. Okay, there's a functional programming paradigm, and there's also the object-oriented. There are other types. Those are like the most popular type of paradigm in programming. And if you use Jupyter Notebook a lot, if you always work with Jupyter Notebook, which I believe most of you will have worked with, you will have been doing functional programming, whereby you have this top-down approach where you have a particular cell, something like this. You have a cell, you write a simple function, you execute it, it immediately shows you the results. So something like a top-down approach where the first cell has to run before the second cell, before the third cell. So if you try to use, for example, maybe a function in the fifth cell that you've not defined on top, it's going to show an error. Okay, so something like that, kind of like a functional programming. But the object-oriented approach is a little bit different. Okay, so if you look at this definition I have here, it says that object-oriented programming is a programming paradigm that provides a means of structuring programs so that the properties and behaviors are bundled into individual objects. So basically, what people do in using this approach is that they model their problem based on objects. Because if you look at the real world is almost everything is made up of objects, or we can even argue that everything is made up of objects, because each object or each person or each entity belongs to a distinct class. Okay, so for example, if you take let's say humans, for example, the human you can represent the human as an entity. Why? Because it has common characteristics. It has common functions that it can do. As a person, you can walk. Another person can also walk. A person can jump. A person has two eyes, has a nose, has ears, so things like that. So we can say there's a person object, there's a person entity. We can also create maybe say machines can be an object. We can also say maybe animals can be an object. So you can see this idea that every entity can be represented as object is the idea behind object-oriented programming. Okay, so that we can take a person and we can bring out all the characteristics of the person. We can take a person and bring out all the functions of the person and represent them as programs. So that is the idea, the whole idea behind object-oriented programming. And why is this good? Okay, so this approach is good for some particular problem. When you have some kind of large scale problem you are trying to solve, it is good because it helps your codes to be cleaner because you are going to be representing each entity or each piece of information in your code as an object. It makes your code cleaner, number one. Reusability, people can easily extend your code because, for example, if they want to fix a particular bug, they know the class to go to, they know the objects to go to, so stuff like that. There's also the advantage of modularity. Okay, you can structure your code into modules. So, for example, you all have been working with packages, libraries, where you import pandas, import numpy, For example, if you want to use a particular function in pandas, let's say you want to use let's say you want to create a series. For example, you do pandas dot series. That series itself is a class, is an object. If you want to create a data frame, you do series dot data frame. That data frame on its own is also another class. So you can see that most packages are bundled as modules, different classes, different objects. If they were not like that, it would be so clustered, and when you are looking for a particular function, you might not know where to go. If you have an error, it will be hard to debug, so things like that. Okay. So I believe we have like a basic understanding of what object-oriented programming is. And also another thing I got here from Python was that an object represents a person, which I've said before, with properties like name, age, address, and also behaviors like walking, talking, breathing, or you could represent an email. So for example, let's leave the person, can be a little bit abstract. Let's talk about maybe an email. Maybe you are trying to create an email program. So you can represent an email as an object in the program. So what are the properties of an email? For you to send an email, you must have the subject, you must have the body, you must have the list, that means the recipient list, who are you sending the email to, so stuff like that. So these are all attributes that an email must have. Then you can have methods or behaviors. What can be behaviors of an email? An email can be sent. So you can send an email. So once you click the send button, it automatically starts this send method. Okay. So an email, you can add attachment. So adding an attachment is a behavior. So you can see we can take this kind of abstract concepts and model them using object-oriented programming. So that's your idea. Okay. So let's talk about what we're going to be learning in this workshop. We'll learn how to define a class, which a class is simply just an object. Okay, so we'll learn to take an abstract concept, maybe like a person, animal, or a student, and define it as a class. Okay, then we'll learn how to instantiate an object from a class. I'm going to explain what instantiate means. And also, we're going to learn how to define methods and behaviors of objects. And fourthly, we're going to learn what is called inheritance, which I'm also going to explain. And then we're also going to learn we're going to talk about extending of classes, extending of parent classes. Okay. So if there are any questions, you can just put them in the chat session. So sometimes I'll just go over it and see if I can quickly answer most of them. Okay, somebody said I like that metaphor of email as an object. Good. Yeah, a cool example, right? Okay, I think brain is handling the questions. So I'll just keep on going. All right, so let's define a class. So we have when we talk about a class is also can also be called a data structure because in computer programming, when you say something is a data structure, it's just a structure that can store data in a particular format. Okay, so for example, in Python, you have things like numbers, you have integers, you have floats. An integer can only take a particular type of number. So if the number that you are trying to assign to an integer is not of the type int, it's going to give you an error. So you can see every class or every data structure has their own properties, have their own characteristics. Okay, so you cannot say an animal is a human, and you cannot say a lion, or let me say a cat. A cat cannot reason the way a human reason. A cat cannot get up and say he wants to go to school. So that's not the behavior of the cat. So every data structure is just a way of embodying data so that it can behave in a particular way. So you have things like numbers, strings in Python, you have the list. The behavior of a list is different from the behavior of a number. The behavior of a list is different from behaviors of strings. In list, you can append, you can add new objects at the end, add new values at the end. In integer, you cannot append to the end of an integer. It shows an error. So for example, let's say Let me just add a new code above. I think I should zoom in a bit. Better. All right. So, for example, if I have, say, A is equal to, so A is equal to 20. I run this cell. If I do A dot append, append is a property of the data structure list. So imagine me trying to append to an integer. So it's going to tell you attribute L. So you see when we talk about attribute behavior, attribute simply means behavior. So it's telling that attribute L int object has no attribute append. It does not have this behavior. So that's the whole reason behind data structure. Data structure just represents information in a particular way. Okay? So defining a class is like Python gives you the ability to define your own data structure. So you can like create it the way you want it. For example, if somebody calls print on your class, you can customize a string that will be returned. If somebody calls add, you can customize what add will do, like stuff like that. Okay, so you defining a class is like creating your own data structure, but Python comes with primitive data structure. These are like inbuilt data structures, number, string, list, and stuff like that. Okay, so if you need to model more complex data structure, you need a better and efficient way. So the idea behind classes comes from this problem. All right. So let me just delete this, delete this, and this. Okay. So let's just take a typical example. Let's say we are trying to build a program for a school, for example. Let's say we are trying to build a program, a software for a school. So you want to build, let's say, a content management system, or a student management system, or a student management portal. Okay. Hereby we have students, we have teachers, we have let's say admin staff, stuff like that. So you can see that the whole, if you look at this in an object-oriented programming way, if you're trying to build a kind of program like that, if you look at it, most of the times what you first of all do is to try to like picture and draw the diagram of the classes that are going to be in that program. So for instance, if I want to build a portal for a school, what I can do is to first of all identify all the objects that are going to be in my program school. Okay, so I can say students is an entity. Students have a particular behavior, so students will be an object. Lecturers or teachers is another entity. They have a particular behavior, so lecturers is going to be another object. Why the father or the super class is called the school. So under school, you have different objects under it. So school is an object on its own. Under school, you have students, you have teachers, you have admin staff. So these objects have their own behavior. So you can create a particular behavior for students. For example, students can have course taking. Course taking can be an attribute of students, but a lecturer does not take a course. A lecturer teaches a course. So for the lecturer, he or she will not have that particular attribute that the student has. So you can see the whole idea behind object-oriented programming is to make applications simpler. So you already know beforehand what each entity will have. So you cannot try to call course taking on a lecturer class. You of course, you already know what each entity or what each object will have. So that's your idea. So just imagine we're trying to build that kind of software. Now we have a student class. Okay, so in Python, to create a student class, you just use this keyword class, small letter, or true. Then you define your class because it always starts with a capital letter for convention. Always starts the name of the class with a capital letter. Okay, so what we've done here is we've created a class. This pass method just simply like tells Python not to do anything. So after clicking this class, don't do anything. So let's run this, and we've just created a simple class called student. But this class currently does not have any properties, it does not have any method, it does not have any value. Okay, so you can say classes are used to create user-defined, okay, I said this earlier, and they have functions and methods which can identify their behaviors, actions, and things like that. Okay? So let's move to this next cell. Now, what we did here is that after creating the class student, there's a special function that Python is called the dash dash init dash dash functions. They are called this kind of functions. Any function whereby you start with double underscore, the name of the function, they end with double underscore. It's called a dunder function. Something like this. Dunder. They're called dunder functions.